All right, hey y'all, it's Mr. Kyle Myers Mathematics. Let's just jump into it. Determine the limit of the sequence or show that the sequence diverges. If it converges, find its limit. So we are trying to see if the limit of the sequence, if the sequence has a limit, meaning as n goes to infinity, what is happening to a sub n? Well, this one actually might be a little bit more interesting than the previous ones. And let's look at why. So 2n versus 2n factorial versus n factorial squared. This one, I haven't actually solved this one yet. And I don't know off the top of my head which one is more intense. I want to say that the bottom is going to infinity faster than the top, but I don't remember for sure off the top of my head. So what we want to do is we want to try to compare apples to apples as best as we can. If you square something, you're timesing it by itself, right? So n factorial versus 2n quantity factorial. So the interesting thing about that is that 2n factorial would be 2n minus 1, 2n minus 2, which would be a little bit helpful because, well, maybe a little bit helpful. I don't know. Let's see. Then 2n minus 3, 2n minus 4, and so on and so on. Let's just do one more, 2n minus 5. And the reason why I can do this is because of the way factorials work. And actually, because of what I'm seeing here, I'm going to go ahead and change one of these into n times n minus 1 times n minus 2 times n minus 3 factorial. The way factorials work, right, is 4 factorial is 4 times 3 times 2 times 1. So if you just go down, you would say, okay, well, 4 factorial then is the same thing as 4 times 3 factorial. You can do the same thing with any number. So theoretically, any number means n, right? N times the next number down from n times the next number down from n all the way until you get to 1. So this is assuming that n is some really, really big number because we are trying to go to infinity, right? So we can assume that n is going to get really, really big at some point. So it's okay to do this. Now, obviously, if n is, in the smaller number range, then this kind of thing wouldn't make sense as much. Although you can kind of dabble in negative factorials, we typically don't, not even in Calc 2. So let's look at what's happening here. We get a couple things to cancel right off the bat. So we get this and this to cancel. And this actually right here is 2 times the quantity n minus 1, right? And then n minus 1 cancels with n minus 1. Same thing happens here. If I take out a 2, I would get n minus 2. And then that would cancel out. So theoretically, every other factorial is going to cancel out with a remainder of 2 and cancel out with one of the n factorials. So that's happening. And then the other one we could maybe write it a little bit differently. It's hard to say, but it would be kind of similar to the other one, the n factorial. So it looks like they actually might be about on par with each other. Because I imagine something similar happening here. We can't quite get that nice factoring to happen there, but this would be like close to 2n minus 1. It's double the n. If we take out the 2, like we did earlier, it's n minus 0.5. So not quite as clean as earlier, but we do get something that would be kind of close to as we go down in n's, n and then n minus 1 and then n minus 2. So I imagine that we would get that to kind of sorta-ish cancel. with the n factorial as well, but we end up with a bunch of leftover 2's on the bottom. So I'm wondering if, as we're going to infinity, the bottom, they're kind of like, they're kind of canceling each other out. It looks like they more or less cancel each other out, but then we end up with so many numbers on the bottom that keep stacking that it's essentially like if we say 2 to the n over 2 to the n plus 1, then this they would be going to infinity just as fast, and so the limit as n goes to infinity of something like this would be 1 because the leading coefficients are 1. Now, what if it was a 3 on the bottom? Well, they still have the same power, they still have the same strength because they're both 2 to the n functions. I just changed the coefficients. That doesn't change the strength of the function as it's going to infinity per se, overall. So 2 to the n and 2 to the n still going to infinity just as fast, but now the limit as this goes to infinity would be 1/3. So, but what if this number kept getting bigger? If this number kept getting bigger, it would almost be like if I wrote it like this, n times 2 to the n. Now that's a different class of function. That's a higher level of function than what's in the numerator. So that looks like that's what's happening here. And I'm not being super technical because I don't prefer to. There is a more technical way to do this, but that would make the video a lot longer. If your professor needs you to show them the more technical way, just let me know in the comments. I'd be happy to make a follow-up video on it. But that looks like that's what's happening here, is that we're canceling out pretty much all the terms in the numerator and the denominator once we factor out those 2's. But if we're going to infinity, we're going to have an infinite number of 2's in the denominator. So you've essentially got 1 over infinity, which is 0. So the limit should be 0. However, just to be sure, I can type this in as a function and see what's going on as it gets to a really big power. So let's type it in. So I've got f of x already pulled up on Desmos. I'm going to put f of x, and then I'm going to have x factorial squared over, and then 2x quantity factorial. And actually, it looks like it levels off really quickly, which is interesting because both of them are factorial type functions, and it looks like because of how closely related these types of functions are, there isn't one function that's kind of taken off a lot faster than the other one, like in the previous problem. These functions are right neck and neck right from the very get-go, and I can easily see from the graph that this is going to 0. Yeah. I mean, it is like very obviously going to 0, even by the time we get to like 20. So if you just try some values in a t-chart on this, you're going to see really quickly how fast it goes to 0. I mean, it goes to 0 within 1, 2, 3, 4, 5 decimal places. So within 5 decimal places, we get to 0 by the time we get to 10, it looks like. Yeah. By the time we get into the tens, we are within 5 decimal places, basically already at 0. So yeah, definitely going to 0, and we can see that from a t-chart. We can see that by canceling out the graph, or canceling out the simplification of some of these factorials and looking for patterns. A couple different ways, but like I said, if your professor needs to see something a little more exact, just let me know in the comments. I'd be happy to do a follow-up on it. Otherwise, go check out the 5 math mistakes everyone makes and how to avoid them. It's a free PDF. It's on my website, hyersmathematics.com. Catch you in the next video. Blessings, y'all.